to to SPSS. And I'm going to take SPS. Before I do that, I'm going to open up another Excel data file. Here's an Excel data file that has 3 columns in it. Okay, and at the top I have basically a summary of what these variables are. I have the patient ID or student ID. These are all students, and patient ID rather. These are all patients. The ID number of the patient. Whether the patient is diabetic. 1 probably means they're diabetic. 0 may mean that they're not diabetic. Data is all frequently summarized this way. And stay represents the number of days that they may have had to stay in a rehab center based on a similar injury or similar condition. Okay, and presumably we're looking to see, we may be in a study like this looking to see if diabetic patients stayed longer than non-diabetic patients stayed. Okay, whether there's a difference in terms of the average stay length for diabetic patients or non-diabetic patients. And we have quite a bit of data here. We have 100. It says 101 because the first row was identified the variables in the columns. Okay, so we have 100 data points in here, the 100 patients that we have this data for. Okay, we're going to take a look at that later on, but it'd be a little tedious with this long a column to work with this in Excel. So we're going to, instead of working with this data in Excel, we're going to actually move over to SPSS and work with data in SPSS. I'm going to start first, rather than with that file, I'm going to start first with a file that's a little bit more straightforward. Okay, I'm going to start SPSS. Now, those of you who have SPSS and have a chance to play around with it are going to have a chance to already have had a chance to look at this a bit. Yeah, the interquartile range is a difference. Let me just answer a couple of questions. Interquartile range is the difference between the upper and lower quartiles. Okay. Well, yeah. When we're talking about, it's kind of funky there because it's such a small data set. But in general, if we're talking about a very large data set, it's literally from the 25th percent to the 75th percent inclusive. So it does include those numbers and the numbers that might be exactly 25 and 75 in there. Okay, so let's start SPSS. And for you guys that haven't had a chance to really look at it yet, that maybe just downloaded or just started working with it, this is what you're going to see when you start it up. Actually, I'm going to do it this way. It's going to be a little easier for me to find. Okay, so let's see what we get when we start SPSS. Okay, first thing, a window comes up, confirms that our license is okay. And then we get a standard box that appears that asks us what we want to do. Do we want to open an existing data source, run the tutorial, so on and so forth? If you don't like this box, you can just check don't show this again and click cancel, and you'll go right into the program. I'm going to leave that. I'm going to allow it to come up again, but I'm going to say cancel so we go right into the program. SPSS then will open let's see, SPSS, well, usually it may open a data set, an empty data file for you. Okay, looks something like this. Oops. Oh, I see what's happening here. There we go. It was just, the window was just closed. It might pop open like that. See, what happened there was it just compressed it into the corner. If you were using Windows, you'll have those little boxes, the X box and the line and so on and so forth to expand and contract windows. On the Mac, it's going to be these red, yellow, and green boxes. Okay, this is the way a blank SPSS file opens up. Looks a lot like a spreadsheet. Okay, actually, it really doesn't have that much in common with a spreadsheet, except the fact that the layout is very similar, at least in the data window. But the data window in SPSS is really just a tool for displaying and organizing data. You don't actually put formulas into these boxes or perform functions within individual boxes. You just literally display data in there. I'm gonna minimize this window. I'm gonna go up to File, Open, and I'm going to ask it to open an existing data file. On my computer, on my desktop, there's a folder, and inside that other folder, we have the files that we were looking at, and male, female heights.sav. SAV is a SPSS data type. Okay, we see that data, male, female heights. I'm going to ask it to open that data for me. and SPSS opens that data file for me. Notice that the columns represent the variables and the rows represent the individual subjects, patients, so on and so forth. In this case, it's student heights. Some of the students are male, some of the students are female, and we got a bunch of them in here. Let's see, we got 364 students represented here, 364 data sets. Okay, so now let's take a look at doing some of the operations that we just did in Excel with the heights of these various students. So I'm going to go and do this analysis. In Excel, we would have typed a formula in here. In SPSS, we go up to the top here where we have our menus, and one of our menus is Analyze. We're going to be working, whenever we're doing calculations, we're going to be going up to Analyze. And you can see all these different types of analyses that we're going to do. So I'm going to say Analyze, and we're going to work with Descriptive Statistics. Even within that one selection, you can see I have a whole bunch of options here. Frequencies is basically just counts. How many males there are there? How many females are there? I'm not really that interested in that right now. I want to go right into doing some descriptive statistics. So I'm going to choose descriptives. Well, now SPSS is asking me, what variable do you want to calculate these descriptives for? In other words, mean, median, standard deviation, variance, just as we did before for a column of numbers. In this case, we want to do it for a column of numbers representing height, right? So I'm going to move that variable height in here and let SPSS know that that's the variable I want to work with for my descriptive statistics. Would it make any sense for me to do it for gender? How about an opinion? Can I do that for gender? Does that make sense? Right. No, it doesn't make sense, right? Because gender is a categorical variable, right? Or another way of saying categorical is a nominal variable. It's male or female. An average gender wouldn't mean anything. I mean, what could it possibly mean? The average person has one breast and one testicle, right? That's not very useful information for us, because that really doesn't represent anything in reality, right? So we're not gonna put gender in there. We're gonna put height in there because that's a numerical variable that we can actually work with. Okay, so now let's go ahead and click OK. And I got to remember I'm recording this stuff, right? I should watch what I say. But at any rate, that's not that bad, right? So at any rate, SPSS does this calculation for us, and it opens an output window. Notice that behind us, we still have that data window. We can flip back and forth between them. Okay, there's our first data window. I'm going to close that. We don't need that. I'm going to go to window. There's our data window. I'm going to go to window. There's our output window. SPSS works with separate windows for the data and for the output. Every time I do an operation, it's going to add it to this output window. And as we do it, it's going to, in this tab window on the left here, it's going to list all the operations that it did. So we can actually use this as an index and click through all if we really have a long string of calculations. So let's see what we got. We got 364 students. We got our count anyway. Okay, we got a minimum height of 60 inches, a maximum height of 76 inches, and a mean height of 66.9 inches, and a standard deviation of 3.6. So the calculations that we did before, the important ones, it did in microseconds for us here for a much larger data set. So this is a lot more efficient way for us to handle this kind of data set and this kind of calculation. That's why I'm saying, it's nice to know how to use Excel for this, and it's very useful because it's on almost every computer that you're going to run into. But this is SPSS is a type of software, as is R and SAS, that are very efficient at doing statistical calculations. Well, now, anybody see a problem with this? I mean, it's very nice that we know the mean and the of all the students, but that's of limited usefulness to us, right? I mean, really, in a study like this, just as before we were contrasting diabetics and non-diabetics, we might be interested in comparing the mean height of males to the mean height of females, right? So the problem here is that I really need to split this data set into two parts. Another way of saying split is to factor it, like you would factor an equation into two parts, or factor a fraction or something like that. So we want to factor this. right? So I'm going to go back to my data set. I really don't have to click on data. I could even work with the other window up front. I'm going to go back to analyze and take another look at this. There's descriptive statistics, descriptives. I only had one box that came up. I'm going to go one drop further and go to explore. When I open the explore window, I get some more options. Well, my dependence list, that's the number again that I want to find the means of. So I'm going to put my numerical variable. Notice it shows a little ruler there for a symbol for numerical. And in the factor list, I'm going to put the gender of the student. In other words, we're going to break up the heights by the gender of the students into two groups, male and female. It's going to do it for us. Okay. Now statistics, it's already checked off for calculate descriptive statistics. It's going to do a lot of them for us. And plots, well, it's going to do something called stem and leaf and so on and so forth. I'm going to add another one to these. I'm going to go ahead and check off what we learned before was a histogram. Okay, and I'm going to say OK and ask us to do all those calculations for us. Notice SPSS goes in and does those calculations. The first thing that you see SPS do is see SPS type out a script or a macro that, or syntax, as they call it in SPSS, which is a description in words, kind of like the way you give R instructions verbally, or by typing commands. SPSS has a function called a syntax function, which works the same way. These are the words that you would use, or what you would type in to do exactly the same thing that we did using the drop menus. Okay, so if you get very good with it, as you get better with SPSS, you might find that this works more efficiently for you. You also might find that some of these calculations give you more options if you use the syntax language than you can get from the drop menu. But for our purposes, you don't have to get too scared about this. You can just stick to the the menus and so on and so forth for the most part. We'll see if we get into anything more complicated. Not likely though. So let's see what we got here. First thing we get is that remember this is all part of the same continuum here. First thing we get is we have 112 males and 252 females. Then we get our descriptive statistics separated by gender. The mean for the males is almost 71 inches. Mean for females is about 65 inches. We also have the median, the standard deviation, the minimum, maximum, the range, the interquartile range, so on and so, and other statistics we haven't even discussed yet, right? And we have the same thing for females. We've got a lot of information here for this data set. In addition to that, we also have a histogram. Well, let's take a look at this histogram. What this histogram is telling us that this is 68 inches tall, 68 and a half, 70, 69, 69 and a half, 70. There are 24 people that are 24 males that are 70 inches tall, right? There are let's see, this would be 66, 65 and a half, 65. There are 4 males that are 64 inches tall, and there are 2, it looks like, that are 76 inches tall, right? So there's this is a distribution. What do we notice about this? We notice that most of the values are clustered towards the middle, and there are fewer and fewer on the outside. And we notice this has kind of a characteristic shape. It has kind of like that symmetrical bell curve. So it looks like the distribution of male heights looks somewhat normally distributed. It looks symmetrically distributed. Let's look at females. We have a similar distribution for females. In this case, it looks a little skewed to the right. We have a few taller females that are pulling this over to the right a little bit. That would be right skewed, correct? Okay, so that's histograms give us a quick look at the data and allow us to visually understand how the data is distributed. Okay, and